Alright, so welcome to this video where we're going to talk about markets for drugs, which, because of patents, are typically monopolies. And in the process of doing this application, we'll review all the main concepts associated with monopoly. To follow along, you're going to need to download the Word document that you can download at the link below this video. Alright, so we're told at the setup that Merck has a patent on Vilazodone, an antidepressant drug that it sells under the brand name Viberg, I think. I don't really know how to pronounce that. The cost and demand for the drug are given below, and I'll copy those down onto our whiteboard. We have demand given by P equals 13 minus Q. This is not written in the typical form that we would write demand. I wrote it this way when I wrote this question because I wanted you to be able to compare the demand curve and the marginal revenue curve, not just visually when you graph them, but also as equations. You'll see the resemblance here. So I've written demand in its inverse form, the way you actually graph it, and marginal revenue is written in its standard form, which is the way you graph it, which is 13 minus 2Q. And now it makes it really clear that these are two curves that have the same intercept, but marginal revenue has just a much steeper slope. And that's why you find the marginal revenue always below the price, always below demand. We also have our total cost curve. It looks like a mess, so hopefully we won't have to use it. 3 plus Q plus 0.5 Q squared. And our marginal cost is given to us. Marginal cost is 1 plus Q. Again, since we're a monopoly, since Merck has a monopoly on this Vilazodone, we didn't bother to write cost in terms of little q, the firm's quantity. We write them in terms of the market quantity, big Q, because this firm is the entire market. If you're a monopoly, you're the single supplier in the market, so by definition, your little q is the big Q. So the first thing we're asked to do is find the equilibrium P and Q that Merck chooses. These are not really equilibrium P and Q in the sense of that we talked about when we talked about supply and demand. These are more equilibrium in the sense of Merck just picks them. It has a monopoly, it can charge whatever price it wants, it can produce whatever quantity it wants, but it has a goal which is to maximize profit, so it'll use that rule. In order to maximize profit, it has to follow the rule of MR equals MC. We're given the MR of 13 minus 2Q and the MC of 1 plus Q. So once we set up this equation, it's pretty straightforward to solve. We get 12 equal 3Q, which means that Q is 4. And now, how do we figure out the price? Well, I think this way of writing the demand curve, where it's P equals 13 minus Q, makes it really clear how we're going to get the price. We're just going to take this quantity and plug it into that equation and get the price. When we write demand in a different form, like Q equals 13 minus P, it's less clear that demand is just telling us our price, but hopefully not too much unclear, so you'd be able to get it in that case too. All right, so our Q star is 4, our P star is, once we plug in a quantity of 4, our P star is 9. So we're going to sell 4 units of this drug, and we're going to sell it at a price of $9 per drug. What is the firm's profit? For that, we're going to have to calculate the total cost and the revenue and subtract them. Or we could do price minus ATC and then multiply by Q. There's a lot of ways to get profit. You should be comfortable doing it lots of different ways, because a lot of the time, when we give you information on a test, it's not necessarily going to be in the most useful format when we report all the costs to you, but because you are comfortable with all these notions of cost, you can manipulate them and get them into the form you need. So our total cost when we produce 4 units is 3 plus Q is 4 plus 1/2 of 4 squared. 4 squared is 16. So that's 3 plus 4 plus 8 is $15. And then our total revenue is P times Q, so that's 4 times 9 is 36. So our profit is going to be 36 minus 15, $21 of profit, which is pretty good considering, we only sold 4 units. Our total revenue was only 36, but the vast majority of that was basically just pure profit. We're selling these drugs at a massive markup, but that's typical for a monopoly. We feel good about ourselves for that. The next thing we're asked to do is to draw a diagram illustrating the long-run equilibrium in the antidepressant industry, and then explain intuitively what's happening to move us to that long-run equilibrium. So this is moving us towards the notion of, in part A, we had a monopoly, and it didn't really have to compete. I mean, in some sense, there are competitors producing other drugs, other antidepressants that compete with us. But now in part B, we're shifting to our monopolistic competition model, saying, well, look, this firm is making a ton of profit. People are going to create other similar drugs, rip-off drugs. If you go to your doctor and ask for an antidepressant, there are many, many antidepressants, and many of them are very, very similar. So that pretty well fits the description of a monopolistically competitive industry. So in our diagram, we're just going to need to illustrate a monopoly with these MR, with these costs, but it'll have to show that demand has shifted in enough so that the firm is no longer making a profit. So let's go ahead and do that. We'll draw a vertical and horizontal axis, P and Q. P is dollars per pill, I'm assuming. Q is in units of pills. We'll go ahead and draw in, it turns out that this is easiest to do if you wait and draw in the ATC last. So we'll draw in the ATC last. Actually, I guess there's a lot of different ways to do it. Maybe I won't draw the ATC in last. So let me draw my MC. It's 1 plus Q. I'll draw in an ATC here. It hits its min point when it crosses MC. And now what I'm going to need to do is I need to draw in an MR curve and a demand curve so that MR intersects MC, say, here at this quantity. And then the firm wants to produce at that quantity, but when it produces that quantity, the demand needs to reflect that it's making zero profit. So when I draw in demand, it's going to have to touch the ATC. So here's my demand curve. It touched ATC at that point. This is a terrible diagram, as you can tell, because I really had to kind of fudge it to make it clear that at this price, the P star equals ATC star. And I'm actually happy it turned out this way, because I want to reinforce that, as I said in section, drawing this long-run MC, long-run equilibrium monopolistic competition diagram, probably the hardest diagram to get right. So you'll want to practice drawing this one several times. This is not like perfect competition where you've already done some work and it's fairly straightforward. You're going to have to practice this quite a bit as you prepare for the exam. All right. Finally, in Part C, we're told the U.S. signs a free trade deal, and the firm now competes with thousands of other generic manufacturers. And is it still a monopoly? So the basic idea here is that we sign a free trade deal like TPP, and now all these drug manufacturers in Vietnam can manufacture generic Vilazodone, which is identical to Merck's Vilazodone, and then ship it from Vietnam to the U.S. You can't actually do this. There's all sorts of restrictions on importing drugs in the U.S., not so much for people's safety, but just to protect monopolies like Merck's monopoly on Vilazodone. And the policy issue here is that a good thing? It might be a good thing if we think that in order to incentivize companies to make new drugs, we need to give them big profits afterward. It might be a bad thing if you think that people need cheap drugs, they need these drugs for their health, and they're really expensive, and monopolies are intentionally making them expensive, so maybe we shouldn't encourage them to do that. In any event, the thing that becomes really clear is that as soon as we open up to free trade, this monopoly is no longer really a monopoly. If you're competing with thousands of generic manufacturers, the mono part of monopoly really doesn't fit anymore. So in the analysis of the rest of the problem, we're basically going to act as if Merck is now competing in perfect competition. They become a price taker. Whatever that world price is, they pretty much take as given, and we're told that it is $6. So the question becomes, if we're now in perfect competition and the price is $6, what would we produce? What do we produce with P free trade equals $6 a pill? Well, it's pretty easy, right? In perfect competition, if we know the price, we know the marginal revenue. So P equals MR equals 6. We set MR equals 6 equal to MC, which was 1 plus Q, if I remember correctly. And then we can solve this for the quantity. The quantity is going to be 5 units. So now, even though the price is lower with free trade, the monopoly is producing more because it no longer has any reason to restrict supply, right? Earlier, the only reason we produced such a limited quantity of drugs was in order to keep the price really high. Here, we're producing even more drugs since there's no real point trying to restrict supply like that anymore. So that's something to think about in terms of review for monopoly. Remember, monopoly is not really a monopoly anymore if it's competing with thousands of other firms. At the same time, the policy issue is, monopolies can be good if they, create incentives for innovation. It's basically a reward for innovation that you get a patent and monopoly profits. But the downside is that lots of people are sick and they die. Lots of people are going to die either way, just to be clear, right? If you don't create monopolies and don't incentivize drug production, you don't invent new drugs, and then when people get cancer, they die because there's no medicine for them. But the flip side is that if people can't afford the medicine today, they'll die that way too. Health economics is really depressing, by the way, so unless you're comfortable talking about lots of people dying, you probably shouldn't go into this subfield. There's one last video on game theory, applying game theory to competition in the cola market, so be sure to check out that review video, which should be in this playlist.